Our planet is alive not just on the surface, but deep beneath our feet. Far below, the Earth pulses with a slow, powerful rhythm, a hidden heartbeat scientists are only now beginning to detect. This is not a heartbeat of muscle and blood, but of heat and pressure shaping our world for billions of years. The ground we stand on is in constant, subtle motion. Imagine a giant sleeping under a blanket. You can't see it move, but you sense its breath. The Earth's pulse is like that. Over millions of years, this pulse lifts continents, creates mountains, and tears land apart. For centuries, we saw only the effects: earthquakes, volcanoes, never the source. Now we know the Earth is dynamic, ever-changing, driven by colossal energies deep within. Understanding this pulse is like learning the language of the planet itself. It connects us to timescales far beyond human history. As we uncover this deep rhythm, we glimpse the restless energy and hidden engine that drive our world. This is our journey into the unknown, to the very soul of the Earth. How did we discover this planetary heartbeat? By listening very carefully. Scientists use seismometers, sensitive instruments that detect even the tiniest ground vibrations. Placed across the globe, these devices form a network of electronic ears, collecting data for years. Amid the noise of earthquakes and ocean waves, scientists found a slow, rhythmic rise and fall, a gentle, regular cycle. It's as if the planet itself is breathing, swelling and sinking over millions of years. This movement is invisible to our eyes, but seismometers reveal the subtle symphony. By analyzing countless tremors, scientists built a picture of the Earth's interior, tracing the source of this mysterious pulse. The discovery was a triumph of patience and technology, isolating a faint repeating signal from the deep. For the first time, we heard the slow, steady heartbeat of our living planet. This deep pulse has dramatic consequences, nowhere more so than in Africa. The East African Rift Valley, stretching from the Red Sea to Mozambique, is where the continent is slowly splitting in two. This immense scar valleys, volcanoes and lakes is the direct result of powerful forces pushing up from below. The pulse acts like a blowtorch beneath Africa, weakening rock and driving the land apart. The crust stretches, cracks and drops, forming the Great Rift Valley. Over millions of years, this process will create a new ocean, splitting eastern Africa into a vast island. Earthquakes and volcanoes like Kilimanjaro mark the rift's restless energy. These eruptions are vents for the molten rock rising from deep within. The East African Rift is a living laboratory, showing the Earth's pulse in action. Here we witness the planet reshaping itself before our eyes. The connection between the deep pulse and the rift is direct and ongoing. Africa's transformation is a testament to the hidden power beneath our feet. The Earth's surface is not a single shell, but a puzzle of tectonic plates. These massive slabs float atop the mantle, moving just centimeters per year. Heat from the core creates currents in the mantle, dragging plates along. This is continental drift. Where currents rise, plates are pushed apart. Where they sink, plates collide. The East African Rift is where the African plate is being pulled apart by an extra hot spot below. As the crust thins, magma rises to fill the gap. This is how new oceans are born. The Atlantic Ocean formed this way when Pangaea split. Sometimes plates grind and get stuck, building pressure until it snaps, causing earthquakes. The pulse beneath Africa is a key player in this slow, powerful dance. It dictates where continents move and where the Earth will shake. What drives the Earth's pulse? The answer lies deep inside in the planet's structure. Earth is layered, a thin crust, a thick, hot mantle, a liquid outer core and a solid inner core. The engine is heat, left over from Earth's formation and generated by radioactive decay. This heat rises through the mantle as giant plumes, like blobs in a lava lamp. The pulse scientists detect is one of these massive mantle plumes, surging from the core mantle boundary. It's not a steady flow, but comes in waves. Each surge is a planetary heartbeat. The African Superplume, one of the largest, feeds the East African Rift, tearing the continent apart. This is the engine room of our world, shaping the surface from deep within. The most powerful forces are hidden, operating in the fiery heart of the planet. Understanding the Earth's pulse isn't just curiosity, it's vital for our future. The same forces that move continents cause earthquakes and eruptions. By mapping mantle plumes and their rhythms, we can better predict disasters and save lives. This knowledge shapes how we build cities and prepare for the planet's inevitable movements. The African superplume offers a window into Earth's history, showing how continents and oceans formed. These forces may have even triggered mass extinctions by changing the climate. Studying the pulse lets us test theories about Earth's evolution. Our planet is full of secrets, and this discovery reminds us there's always more to explore. We are small inhabitants on a vast, dynamic world. As our tools improve, we'll keep listening to the Earth's whispers, uncovering the secrets of its fiery heart.